Hello, I'm Andre Day. I'm Andre J, and today I would like to talk to you about 3 of my video synthesizer instruments as a part of the video synthesis ecosphere VSERPI. So the one I kind of want to focus on is called Artifical Life. It's the one that you see is generating these patterns here. Artifical Life is a set of digital video oscillators. And the kind of unique, fun thing about Artifical Life is that it is, it's actually about 4 or 6 or 8, depending on how you count, video oscillators which are locked in various kinds of feedback loops, meaning that you can use aspects of one video oscillator to displace another video oscillator and then feed that right back into the first one. So what you can do with this is it allows you to do sort of more complex stuff than like the basic sort of things you could do with like a singular video oscillator unit usually aren't that complex. Like one video oscillator you're allowed to control like, you know, like something that moves this way or something that moves this way. You might have like a couple of shapes to choose from, and you can change like frequency and rate, but that's usually just about it. What this video oscillator system has is it's got some drawbacks to being digital. It's only grayscale on its own. I'm running this through a colorizer right now, which I'm going to also talk about in a bit, but basically having just like a set of the video oscillators locked in sort of signal feedback loops is a way to get really just a nearly like a functionally speaking, from like the viewpoint of just like a user, it's a functionally like infinite number of variations of what you can do with these oscillator systems. It's not actually infinite, I don't believe. But just in terms of like what you could do with it in a lifetime, you might not exhaust everything that you could do with just this system on its own in one lifetime. That's kind of how I like to make things. I like to make stuff that like, you know, is more complex than you can like realistically deal with in a human lifespan. But yeah, it's totally grayscale, which is why I've also designed a colorizer unit. And so I'm running this through 3 of my units right now. I've got Artifical Life at the top of the chain, and that's doing these shapes, and I'm running it through a colorizer / solarizer. I'll go more into that later. And then after that, I'm running it through Waaave Pool, which is doing this kind of video delay stuff. And I'll talk more about what exactly I'm doing with the Waaave Pool later, but you can see this is with Waaave Pool off, and this is with Waaave Pool on. And when I get to the Waaave Pool portion of this, I'm going to talk about sort of, usually when I talk about Waaave Pool and I use it, I'm talking more about like doing like crazy intense like reaction diffusion feedback things. And this time I'm going to kind of show you how to do some more like subtle, like just like delay stuff. Because Waaave Pool is a video delay pedal with feedback and feed-forward modes. I'll go through each one of those and show you how you can do sort of really amazing stuff with just this sort of like basic geometrical masking input. But yeah, so Artifical Life, let me just start this off from basic patch. So there's a reset button on here, which is kind of handy. So usually when you boot up Artifical Life, you're going to see something kind of like this. But in grayscale, of course. So it's just like slowly moving horizontal lines here, and then we have a bunch of different ways that we can affect the orientation and sort of like general shape of these lines. Like you can see right there, we can bend them around the center point and make this sort of like radial oscillator. We can change the overall like so there's frequency and rate. Rate being how it changes between the screen, between each frame draw, and frequency being how many times it's drawn per frame. And you can see we can get a little bit of moire happening here. Not full moire, but once we do some feedback things, then you can definitely see some more moire. Yeah, you can kind of just do this thing where you use it as sort of like a very pulsy kind of thing. And then we have, you can do sine wave, you can do square wave, and you can do saw wave. And you can see that the different gradients that this gives you feeds in some pretty interesting stuff to the colorizer unit. But I'm going to stick with square wave for now, because I feel like this works really well with the masking. Then we can take another oscillator, so we can take our other main oscillator, and we can use that to displace the phase, use a phase offset from one oscillator to another. So this is if the other oscillator, let's just take a look at that one. This is what that other oscillator is doing. So you can switch back and forth between the two main oscillators, and we can see that it's just sort of doing a phase offset, but because the other oscillator isn't running, it's a fixed phase offset. If I start up the rate of this one, start it moving, then we look over here and we can see that it's already starting to do some more interesting things going on. I can change the frequency of it, and we can get some pretty strong blobby things happening on. So that's what it looks like on the one side. Here's what it looks like on the other. And then there's, for each of the oscillator 1 and oscillator 2, we have these dedicated modulation oscillators. And what I mean by like dedicated modulation oscillators is, so here's oscillator 2 on its own, and let me go into the modulation oscillator and use that as a phase offset. And the modulation oscillators also have a little fixed feedback loop that grabs in from the what do you call it? From the other main oscillator. It's allowed for this sort of like, this is where you get this kind of like crazy patterns that are happening. This is phase modulation feedback loops in video oscillators. And this is kind of one of the really unique things that is nice about working with digital video oscillators, is that you can sort of control and tame this signal-based feedback a bit better than you can with analog video oscillators. And it's also much, much cheaper, because if you wanted to have 4 analog video oscillators and like a way to like, you know, a nice way to like mix them all together with some sort of filtering, that would be kind of expensive. But this unit is just one standalone thing that kind of does all of these things on their own. So yeah, that's pretty neat. And then we also have amplitude modulation. Amplitude modulation slash, it kind of works like ring mod and or amp mod, so it's like variable amp ring mod. What amplitude modulation means in a video feedback or a video synthesis setting is amplitude sort of refers to brightness. So basically we use the brightness of the entire frame of the video oscillator to offset the brightness of the next one. So that's what I'm doing right now, is I'm setting them both up. We can use that either to like generate more like masking kind of things if I set them both to the right amount, or we can use these to do some more crazy feedback things, like you can see happening on the edges of all of this stuff. And yeah, as far as Artificial Life goes, like this is sort of like one of my like passion projects. Well, the idea for Artificial Life came from a couple of different ways. I'm just going to kind of like ramble about these units for a while I sort of casually do stuff in the background, and I'll get back to explaining what's going on in the background, but I'm going to try to like just make some visually interesting thing happen while I talk about the units. Yeah, so there's sort of 2 places that Artificial Life came from. The first one was from playing around with VSynth. Some of you might be already familiar with VSynth from the tutorials that I do live on my Twitch channel, and they're also posted on my YouTube as well. I do them every Tuesday night. Well, I don't do VSynth every Tuesday night. Every Tuesday night I do a live tutorial workshop thing on Twitch. So I alternate between VSynth, Hydra, and video waves, just to keep things, you know, spicy and whatnot. But VSynth is a digital video synthesis system built in Max MSP. by Kevin Cripper, and it's a pretty amazing system. And I started using it, I started playing around with it just pretty recently, maybe in the last year or so. And I noticed when I was playing around with it, the first things that I would always kind of do is like just feed the oscillators back into one another and just play with that as sort of the main goal. And I was just kind of curious if I wanted to try like designing my own to see what happens when I could like just experiment with the code and the design side of things. So that's one place that I sort of started off with the old Artificial Life. And then the other side of the Artificial Life development came from sort of like my history in coding and history in working with like video synthesis and video design in a coding world. A lot of it started with I would be like interested in trying to like look at something in nature and then modeling it. One of sort of my favorite projects that I would return to over and over again was ripples on a surface of water. So the thing I was interested in was mathematically modeling a graphical synthesis system that would sort of do like just like wave interferences and waves moving upon waves and whatnot. So I looked into that. I looked into the math side of things because I have a history in mathematics. That's sort of another one of my passions. And you could say that all of this video synthesis stuff is just sort of like, it's applied mathematics for me. It's just amazingly fun and a really great way that I managed to like use my degree and not be in like academia. Thank heavens. Yeah, so I was thinking about ways to model wave interference. Because say you have, so it's pretty easy to do just like one drop ripple outward. Like we've all seen that effect done pretty often. It's not remarkably complex to do in a code-based method. But what I was more interested in is what happens when you have multiple ripples. Like, so I have a drop coming here on a surface of water, and then I want to take another drop of water and have that interact with the other. And we think about them maybe being in sort of like a fixed little surface, so the waves would also reflect off the edges. Right then and there, when you start doing multiple waves and you have them bouncing off of things and like interfering with one another, that's when directly trying to manipulate them gets kind of difficult. Usually, I think the actual mathematics for directly computing those things in sort of like a differential equations sort of manner is involving like Bessel equations, which are remarkably complex and not super fun to try to like compute on the fly. And another thing I've always been interested in is just like algorithm design and how to sort of like this idea of like algorithmic information theory, where you can take like a really complicated set of ideas but encode them in a really simple and concise algorithm. It sounds very theoretical, but it's actually really about like how do you write a very simple program that can execute on, say, like a Raspberry Pi that can do a functionally infinite number of things. So this is directly relevant to like all of my like design and interests. Yeah, so when I was thinking about that, I was just like, okay, so you have one wave going like that, and then the amplitude and the frequency of that wave are going to also affect the amplitude and the frequency of another wave. So as these waves interact, the actual equations for these waves, you can think of them as just updating in time steps, because everything in the digital world updates in time steps. There is no continuous when you're working in a digital system. It's always a discrete time step. So you can just say, okay, well, maybe I just have two equations. I have oscillator 1 and I have oscillator 2. And then at each time step, we update oscillator 1 as a function of oscillator 2 and vice versa. So we lock these oscillators into feedback loops. And through a lot of trial and error, and through a lot of like playing around with gain staging and various sorts of like very crude numerical filtering, I started to come up with these really fun, super chaotic systems. And that is also sort of like the other way that I like birthed Artificial Life. And sort of the reason that I gave it the name Artificial Life is because a lot of my things, I try to make things that look and feel alive. There's, to a certain extent, when you look at like a very standard video oscillator where it's just sort of like moving at like a fixed frequency in one direction. It's very rigid. It doesn't feel alive to me. It feels static because it's just sort of like when things just like repeat too mechanically like that, you get all of the information in a very short amount of time, and you kind of say like, I see where this is going. Whereas like living systems are always sort of involved in some kind of a feedback loop, and that feedback loop gives sort of it'll make things repeat, sort of, but like slightly different every time. It's kind of this idea of like edge of chaos, which was the edge of chaos was sort of like a hot topic in like the late 80s, early 90s in complex systems theory, because it was like talking about this idea that like a lot of life systems, a lot of natural systems seem to live in this sort of like complex feedback systems that like have a lot of dynamics and have a lot of sort of like self-reinforcing patterns in them, and like entropy minimization in the grand scheme of like how entropy is generated in the universe. And yeah, it's just sort of like a large part of how I like to design things, because part of my design thing is that I have to sit and like look at the systems and like poke at them and play around with them for hours on end. So no matter what I'm designing, I want to make sure that it's going to like be interesting to be involved in the whole time. So like that's sort of like my design thing. Like the first thing I do when I design something is I try to make it fun to work with and visually interesting, and like it has to be a interesting system to play with from the start. Otherwise it's just kind of a grind to work on. But yeah, seamless edit point here. That sort of sums up like where my influences come from for Artificial Life, and kind of why it's one of my favorite projects I've worked on so far. But next, I want to talk about my colorizer. So the thing about the colorizer, it's called Chromatic Aberration, the search for Sasquatch. So unlike Artificial Life and Waaave Pool, the other instruments I'm using in this chain, Chromatic Aberration isn't for sale. This is one that you can just use for free if you have a Waaave Pool or Artificial Life or Spectral Mesh. Because the way I've designed this system, I want to take a moment to just talk about the system. It's pretty much like a Nintendo or something. So I call it the Video Synthesis Ecosphere Raspberry Pi because I'm very obscure in my titling. But also, I had to come up with a name for the platform itself, because I wanted to make sure people knew that this is like a platform where you can sort of like interchangeably use SD cards as like game cartridges in this world to like swap out for different kinds of video synthesizers. So essentially like a Waaave Pool, Chromatic Aberration, and Spectral Mesh, and Artificial Life, and Phosphorm to a certain extent are all basically the same hardware set, just with different firmwares and different kinds of accessories you can use with them. And part of something I wanted to make this system was to just have like a bunch of like extra freebies that you can, if you get one, you can run them all, and you can run some like free bonus things. And this colorizer is one of them. It's partially because the colorizer is kind of limited in scope. It does some pretty amazing stuff, especially with Artificial Life, but unless I can figure out some way to really like jack it up and make it more than what it already is, I wouldn't quite feel right charging money for it, but I do feel perfectly okay sharing it as like freeware for everyone to use. And then the other thing about this system is that you can build your own. It requires no soldering. It's about as complicated as putting together Legos. There's instructions on my website. And once you have this system, you can play any one of my images, Waaave Pool, Spectral Mesh, Artificial Life, Chromatic Aberration, Super Heckle 64, and you can play some things that other people have made. Nicole Pichon has made a couple of really neat instruments for this system. And it's an open source system, meaning you can also make your own video synthesis instruments. I've included with the Waaave Pool distro and also on my GitHub, there's just like a sort of default getting started how to like write your own video processing thing that sort of walks you through example functions, example code of how to like do, just like take in a video feed, do some sort of mild alterations on it, and send it out. So yeah, that's the system. So the chromatic aberration works. I made this one because I had never really played with a colorizer, and I was just interested in the idea of exploring it, but there really aren't that many colorizers available. Right now, since I made this, there have been some more that have come out. Bastian over at Syntony has released another open source colorizer called the FFG, which is pretty amazing, and I recommend checking that out if you're interested in building things, or you can buy a pre-made one from them as well. And then I think that some of you might know who Rob Schaefer is. I think they have some designs for an open source DIY colorizer as well that Tim Caldwell is helping make PCBs for. So those, I don't know if they're available or finished yet, but some of the instructions for putting those together will be out at some point. And if you've seen Rob Schaefer's work with colorizers and video synthesis in general, then you should be pretty excited about that. But colorizers, just for some context in what a colorizer is a unit that takes in like black and white video, or it can also take in this case, it's taking in, well no, it's taking in black and white video. But you can also feed this one particularly. You can feed it color video and it'll just ignore all the color information. So it just takes a grayscale gradient from black to white and then allows you to map that gradient to a color. So pretty simple. The main reason that colorizers were invented in the first place was for colorizing black and white video. So it was sort of simpler and cheaper to just take black and white video, take the old black and white movies, or shoot in black and white, and then use the colorizers to add color to it. They were also an incredibly important component of all sorts of like special effects systems of like the 60s and 70s. The Scanimate being like the most like notable one of those, I think, but a lot of the other ones that were based on like, so any sort of, especially any special effects video synthesis system that was built off of rescanning the output of an oscilloscope or a modified oscilloscope, those would always be in grayscale, so you'd have to add color afterwards. So it might seem kind of limiting to just be able to take a grayscale and then map that into black and white. You can say, oh, I've seen Scanimate stuff. It's not monochrome. It obviously is like, it's got very lush, robust color and everything. So how did they get multiple colors from just this description of a colorizer? And the answer is that you can get around that by just like taking bands. So I take like, so the Scanimate had an 8-band colorizer, I believe, at the end of the chain, which is just gorgeous, soft, lovely colors. You would not, you'd look at that and you wouldn't say, oh, this is something that was like, obviously like a raster scan thing from from the front of a modified oscilloscope. You feel like this is sort of like a living, glowing, like realer than real kind of sense from it. And that's sort of the really neat thing you can get from a colorizer is this like hyper real sort of like texture thing going on. But you separate your gradient into bands. So this one, the Chromatic Aberration, is a 4-band colorizer, meaning like we take so I'll show you, like, here I've removed all the color except for the lowest band. So we can see just sort of in the darkness, that color is amplified, and I can select a different hue for it. And while I'm sort of only giving it like a monochrome hue, the way that color and light interact, because there's a gradient happening, makes it feel, it gives it like multiple, a different sort of like color thing in our texture. It's also getting some extra colors because it's running through multiple ones of these capture devices, and the capture editions on mine, while they're pretty nifty, they do some artifacting. Once you start chaining up a couple of captures one after another, you'll notice these sort of like artifacting things adding up. But yeah, so that's like the lowest band with color, and then you can control the saturation individually on each band too, which I think is really important. Meaning you can do super saturated things or like more pastel, subtle stuff. Here's like the second band. Here's the third band. And then here's the final band, the brightest band. And then there's a couple of buttons on here that allow you to sort of like remap the whole band thing differently. It's just sort of like changing the color curves, if you're familiar with how color curves work. And then you can also remap the brightness on each one of these channels as well. So you can use this as sort of like a multi-mode solarizer. And what I mean by remapping the brightness is I've selected the lowest band of brightness and I'm just driving it up. And let me select the highest band of brightness and drive it down. So now this is pretty similar to what a solarizer does. You can kind of like draw your own brightness curves as like a brightness wave shaper on this thing. And then one more thing that this can do is we have individual oscillators for each one of the bands that can oscillate either the brightness or, well, they can oscillate the brightness and the hue for each one of these bands. And these I'm still kind of working on. I think I might have some better ideas for them in the future, but they work pretty well at the moment. But you can see I've taken the two bands that I messed around with in the solarizing thing, and I'm oscillating the brightness on them, and now I'm going to oscillate the color as well. So yeah, that's more or less Chromatic Aberration, the search for Sasquatch in a nutshell. And stay tuned, I will be releasing an updated version of that, the version I'm playing with right now, this week. This week being the 2nd or 3rd week of August, I believe. It's the 2nd week of August, it's not the 3rd yet. But yeah, I designed it, one of the main reasons I designed it was just to explore colorizers, but then when I started playing around with Artificial Life, I was like, oh, Artificial Life, it's going to be way too complicated to try to like pull the put color information in that one. So I was like, I will instead just devote more time into playing with Artificial Life and Chromatic Aberration together as like a unit for like a single purpose unit. Because that's the other thing about video oscillators is usually when you're working with them, you only are working with the grayscale, the black to white sort of thing on them. And you have to, if you have a video synthesis, an analog video synthesis system, you add color later, usually based on some sort of like colorizer type thing. And yeah, I might be interested, I really like, probably the more I play with VSynth, and the more I play with Hydra, the more ideas I'll get for sort of things like bonus images that I can add to this whole system. And usually the bonus images are like this kind of a thing where they're just like one single purpose, like really functional kind of doohickey. I've got the other one, which is Super Heckle 64, which is just sort of a really fun pattern generator, I guess, using the super formula. It makes a lot of organic, crazy shapes like radiolarians, which is why I called it Super Heckle 64. But yeah, so let me just dial in. I had some really nice pastels on this before. Make sure I'm back. Actually, yeah, I kind of like this specific mode right here. Let me get some pastels happening and everything. This will be pretty fun to run through the Waaave Pool. And then at the end of the chain, we've got Waaave Pool. And Waaave Pool is video delay and video feedback generator. And usually when I'm goofing around with Waaave Pool, I focus on the feedback things. But now I kind of want to talk about more just like nifty things you can do with this as just like manipulating video delay. So on the Waaave Pool right now, I'm making sure not to really like affect hue, saturation, or brightness this much. And I also have the delay set to a larger amount. If I turn down the delay, we've got that, where we get this sort of very fast-moving, intense, busy video feedback going on. But if I just turn down the delay time a bit, And especially with the kind of like smoothly, continuously morphing like input image, then we start to get some really like crazy psychedelic like alien landscapes coming out, where like just because it's like delayed and being shifted off a bit. And then we can also shift the zoom out. And then this is kind of one of my favorite modes to like displace a lot. And then we slow it down. And then I just sort of like slowly key out the source image. And then we get this kind of like fun like echo chamber. It's like a video echo chamber thing happening. And then we can do a total delay of like 2 minutes. Not 2 minutes. 2 seconds. Oh my god, 2 minutes of delay. So you see, the more I slow it down and the slower that I key things in and out, the more kind of like echoes that happen in this echo chamber mode. And then we can also move it around geometrically. But yeah, something else that I like to do with the Waaave Pool when I'm working with like a system like this, like a sort of oscillator-based system, is Waaave Pool has has in addition to feedback mode, a feed-forward mode, meaning that we just take a delayed copy of the original signal and you can just like manipulate that. So if I do crazy things to the position in this one, it's not really going to do feedback. It's just like we zoom in and we see like, oh yeah, those are some crispy edges. Digital video oscillators. Crispy edges. So you can just move the position around. And a neat thing you can do with that, yeah, you can also change the color. We do still have like a sort of like video filter thing that you can like blend with the previous frame and do like differencing with the previous frame. That works way different in feedback mode than feed forward mode. But kind of what I like this specific mode for is you can use it to sort of like compose things. So you can like zoom it out a bit, and then I can rotate it. And then we just have like, if I turn it off, you see this is just the signal that's going in. And then I can add in this delayed copy of the original signal, but with like hue manipulations and stuff. Maybe I make it a bit simpler. I'll hit the reset button on Artificial Life. So there's sort of like just using it as like sort of giving another video oscillator in the background there. But if I instead turn on feedback mode in here, then we're going to get them sort of like building up in the background there. And I'm going to start to oscillate the colors some more. Bring down the saturation a bit. And I'm doing this with Toroidal Universe turned off because I kind of want it to be a little less busy. I can turn Toroidal Universe on if y'all want to see what that looks like, though. So now I'm doing a lot, as you can see, to the hue and the saturation. I'm going to turn down the brightness a little bit so it'll fade out as we like go down. I'm going to turn up the saturation some. You can see in this Toroidal Universe mode, it's sort of like got this fractalized thing going on. And because I have the delay set to so slow, the fractalizing is happening really slowly, as opposed to this mode where it's a fast fractal. Fast fractal. Slow down that fractal. Yep, the fractal will be speeding. Yeah, if you've seen some of the more recent things I've been doing with VSynth in our workshops, you can notice that there's like a definite link between what I do in VSynth and what I do in this system, because when I'm playing with video synthesis, no matter what the system I'm doing, I have a sort of basic fundamental approach to things where I just try to like establish some sort of a simple system for generating complex behavior, try to like play around with signal-based feedback, try to play around with video-based feedback, and then just like toss those together in a pot and shake it around, and kind of like almost no matter like what you do, it's going to be fun to play with. So yeah, you might notice this sort of stuff is looking very much like the things I covered in my last VSynth tutorial, and that's not an accident because this is, what I'm stoked about in life. Let's do a hard reset on A-Life. Turn up the color modulation. over in Chromatic Aberration. Set the feedback a tiny bit. Let me saturate everything. So now I've got Chromatic Aberration at full saturation. Set up each one of the brightness channels to oscillate as well. Start doing some radial modulation. Turn off two of the. Let's turn off a couple of brightness oscillators, not all of them. Turn the delay up a bit. Something else I'm definitely going to be exploring in the future for these devices is using a more dynamic way to modulate the various parameters. So something I really like in both Hydra and VSynth is that you can use full textures, like full frames from different video sources to modulate a parameter, like Z. So for example, in this, say I was able to use the footage of me to modulate Z in this in the feedback of Waaave Pool. So like my brightness, the position of my very bright large forehead as I move it around could be used to displace things. I don't think I'll be able to do it in this system, but I'm going to start work. I have started work on another sort of heavier duty, more robust system for development of video synthesis tools, and that will definitely be a place where I can do sort of, can have like a video Waaave Pool version where you can send in two cameras or two video sources and use one video source as like a displacement, like a modulator. So the brightness on my video source could be used to modulate X, Y, Z, rotation, theta, like all kinds of interesting stuff. So stay tuned for that. Oh, excuse me. Something else that is coming up in the future that I'm working on is for the same system, for the Raspberry Pi video synthesis ecosphere, I'm going to work on some video synthesizers that also work as audio processors and use the audio to drive video. It's not exactly going to be like an audio visualizer in the traditional sense, because these will be fully functional audio processing units. Because I have a bunch of different audio processing software things that I've written before for my own fun. And I just kind of need to make them a little bit more rigorous for other folks to use. But I think folks, if you like experimental, weird, unique sounding things, will enjoy the audio things on their own. But as a bonus, the same controls that you do to audio will be generating and manipulating a video signal, which is generated internally. So these will be units that you don't need to send a video source in. You know, most of my units require a video source. Well, actually not. Artificial Life doesn't require a video source. You can plug video into it to use video to do phase offset on oscillators, but you don't have to. I'm running it without anything, with just the nano control plugged in right now. But yeah, there'll be more standalone things. They'll have a little LCD screen that shows the video thing, so you don't need to plug it into another system. And they'll be, yeah, sort of based around the same setup as the Autowave. So if you have an Autowave, or you're thinking about getting an Autowave, you might be interested to know that there'll be more instruments coming out that sort of do unique things with that setup. So yeah, check out the Autowave too. I would have put it in this one, but it's, you know, it's already like complex enough. But maybe next time I'll do an Autowave with like a bunch of the other video processors as well. Maybe Autowave into Spectral Mesh, I think, is a really nice combo. Autowave into Spectral Mesh, or Autowave into Artificial Life. Because like I said, Artificial Life can take video sources too to drive things. So I don't think I've tried video waves or wave pool into Artificial Life yet. The combinatorics on this, it's wacky. But yeah, those are two things forthcoming that I'm pretty interested in. Work on the CV expansion board is coming along really well, and I think I can't give a date yet on when pre-orders will start, but I mean, it's like 99.9% it's going to be this year. Likely to be within the next couple of months. We still need to work a couple of things out, but most likely pre-orders, you know, soon. Yeah, I'll just say the first sort of audio to video generator audio processor is going to be built around the idea of like, sort of like if you've ever played with granular pitch shifters or granular delays before, it's going to be an instrument which does a lot with granular delay, and it'll kind of focus on being like I found a lot of digital audio tools sort of try to make themselves not like hide their digitalness. Like there's definitely like this vogue right now, and has been for a little bit. It seems to go back and forth every like 20 years or so, of like people being like, oh, analog, like it used to be in the 90s, like analog is garbage, like digital is the best, digital synthesizers are the best, digital everything, go digital. That analog stuff is large, heavy, hot, and, you know, all like garbagey. And then like right around like 2010 or so, it was like, digital is trash, it's digital everything, barf, give me analog. Analog's smooth and warm and alive, and digital things are cold and dead. I don't know why I went off on that tangent. I think analog is great, and I think digital is great, and I think the best things happen when you combine analog and digital together. But yeah, I was saying a lot of digital instruments, a lot of design and DSP goes into making them seem not digital, to emulating analog things. And, you know, my general interests, like, just in terms of a design standpoint, I like to sort of take the essence of the system that I'm working with and use that to the best of it. So if I'm working with a digital system, like grab the fun things you can do only in digital and like amplify them, like the sort of like weird wave shaping, wave folding control you can do. The you can like fine-tuned control like how like signals degrade. Like with analog, you're sort of locked into a very specific way that signals degrade, whereas in digital, like you're just swapping buffer things, and nothing really ever degrades unless you like go out of your way to make it degrade. And there's like a lot simpler ways to, and more like creative ways to make things degrade than to just give it that sort of like tape saturation. Tape saturation sounds great, but yeah, I think if you like what Waaave Pool does with video, you'll certainly be interested in what this mysterious thing does with audio. Oh yeah, I'm almost running out of battery here, so I've got to finish this up soon, but one more thing I wanted to say is if you've seen my time displacement, that is also going to be forthcoming this year as well as a video processor. The name for that is Temporal Vortex, so yeah, stay tuned for more stuff on Temporal Vortex. Alright, so that's about it. I hope you learned a thing or two about artificial life, about the chromatic aberration, about my video synthesis system in general, and maybe a couple more fun things about Waaave Pool. And yeah, have fun.